advantage of a lot of these when they package them into these functions that do things like make maps. And you can load the library, set up a color palette, and then you set up the data frame that you're feeding the data in. That's the leaflet. And now we can just add tiles, so that adds the background base map. And then this adds the points on top, colored by your color palette. And this works, meaning that this becomes interactive within our studio, so right within your IDE. So you can zoom in and out, you can click on points, all the functionality that you add to that. And it can also be active in R Markdown, meaning you generate it to a web page, and then you can host it on a website for free. And then you can also put it in Shiny. Now Shiny, what it adds is it allows you to, when you click on things and do things on the interface, you can have arbitrary functions that you define on the back end that do whatever you want it to do in response to some user interaction. So that's where you need a little server-side help, and it can't just be stored on a free website. Yeah, it's pretty much, it answers most things I need. Okay, so that was it for the data science side. That's kind of the tools, the playthings. For now, applying it to things of interest. So I want to start with just a few simple examples so you guys get the idea. This is from a meeting I went to in November in Senegal to set up a manual for indicators for looking at for Sustainable Development Goal 14, which is something that Frank got me interested and into with the MBON, and we're actively developing indicators on new indicators with biodiversity. This is taking existing data and clipping it down to a country of interest, and then creating maps and plots and figures with the Sea Around Us project that produces global estimates of fishing. And then also the World Database of Protected Areas is a database that tells you where the protected areas are. So these are targets in the United Nations Sustainable Development Goal that every country is encouraged to report back on. A lot of them say they don't have technical capacity, but this is free, online, and very easy to do. So, let's take a little look at what one of these things is. So the meeting was hosted in Senegal, so I set up just a little R Markdown website, and using Git and GitHub and RStudio, I made it on my desktop after I created on GitHub a repository, which is just a container of folders. So let's see what that looks like. And okay, so this is GitHub. And this is the default view, which is just we're looking at files. We see all the files, and then this is, every time you commit, that associates all your changes with a message. So that was the last message based on when I committed this a couple months ago. And this is all in this index.rmd. So I did this in RStudio, and then I pushed it to GitHub. And this is not very compelling yet, but here's an example of what you can do with it. So it can create a website, and then we can have indicators. So this is now a static page, but it's using JavaScript on the client side to allow you to zoom in and out with this little leaflet map. And all the code to generate that was done with, okay, here's get the EEZ, and I have a little function called map the EEZ, which spits that out. And then, okay, let's go and get some catch data. So there's a Sea Around Us R package to go get the catch data, and then we can show the data. And we can plot it out. And then this is using ggplot, and then you can take a ggplot object and then make it interactive with ggplotly. So I can, click things on and off and zoom in and out. So these things can work in static and interactive mode a lot of times. And the idea was, with this country, they wanted to see something where they wanted to reduce foreign fishing, and they wanted to reduce unreported fishing. So then we could come up with a score that does all three. So this is all the data wrangling to group and join data, and yeah, and then we create a little ggplotly object, and then we spit it out. So this is, you can either, by default, you don't need to show the code. It can just generate this stuff. But that's the basic idea. And now here's the other thing about GitHub, is that you can always do this. You can just go over here, anything you see, you can fork. So if you don't have the right ability to write to this repository, I can fork it, copy it into my own space, and then tweak it, and then create something new. So this same, which is what I did over here, I forked it, changed the country code, and now we've got fish stocks for Trinidad and Tobago. So the only thing that changed in the actual code was a country code at the very top, and everything else gets generated for another country. And they could tweak it to their own liking, but that's the beauty of reproducibility, and that's the beauty of open source. Yeah. And that's what I'm trying to share here, is just, this is kind of the little example, say like, here's what Git and GitHub is. So basically on your desktop, you might create, usually the workflow, there's several ways of doing this stuff, but usually I would create a repository, like an empty container on GitHub. Then I would clone it, meaning, so these are just words that follow the git command, and clone. And that gets it onto my local desktop. Then I make some edits. I commit with a message to those associated edits, get bundled with that message. And then it's still on my desktop, and then I push it to get it back up onto that global repository, which can use this other thing called GitHub Pages to host a website, which is what I was showing you. So there's the file view, and then there's the GitHub Pages, which is the website view. And then if somebody else edits, then I can pull to get the latest edits back onto my local desktop. So you have enough people, you can collaborate with anybody to do those basic commands if you all have the same writable space. Otherwise, if you only have read-only, then you can fork it and then into your writable space, meaning there's an owner, which is a user or an organization, and then the repository name. So I know that's a lot if you have never been exposed to it, but this is a distillation of it, and hopefully it becomes less weird when you encounter it again. And these are all active links that describe what each of those things do, so you can go back and check that out. Cool. Okay, so here's another recent example of creating a package in R. Again, that's just a bundle of functions to easily do something, and then generating an output with that package. So this is the website that you can easily generate from a set of functions that you document, and then you can categorize them. So in this case, the Benioff Ocean Initiative is trying to reduce ship strikes of whales. So there's a voluntary slowdown area, and the slower boats go, the less likely there is of lethal impact. So the question then is, using AI's data, where are ships compliant? Is it a company that's, what incentives could there be? Could there be more financial? Could there be a public shaming? What can you do to incentivize? So taking that data, you can create a dashboard that then sets up a directory of all the ships, and then a map, and then analyzes, creates the ship segments between known locations, analyzes the speed, and then maps out the percent compliance over distance traveled. So all these functions, so mapping the ship limits, that's this, the red and green, if it's below or above the compliance or the recommended slowdown speed. Map ship segments, that's on another tab of this. and the show ship box and show ship gauge. So that's the box and the gauge. So it's very simple then once you have the building blocks to create this kind of thing. So we can look at this one. And this is the, again, the repository, the code view. And we can see this uses something called a parameterized report. So I can have a ship name, and I can just render that R Markdown document with a new ship name and generate it for all the ships. And it uses this other thing called Flex Dashboard. And that's just a way of laying out, using those functions, show the ship box, show the ship gauge, map of ship limits, map of ship segments. And that's it. So what does this look like? And then the directory looks kind of similar. So this is the directory. And then you can click on a given boat, and then you get the interactive, and you can even see the speed, or actually the speed over here for those same segments. So yeah, okay. So I would say those are actually relatively simple examples of doing stuff very easily. The Channel Islands, so this is actually started as an Mbon effort, is to make their condition reports more streamlined. So every 5 to 7 years, the National Marine Sanctuaries creates these condition reports, and how can we make them interactive, online, and up to date? So it's not, we don't have to wait 5 to 7 years for the next one. And how could that inform management sooner than later? And can we take advantage of these free tools and the existing R kind of expertise across NOAA to, as a community, build something? So we have an R engine, which could actually live on my desktop, or there's this other thing called continuous integration. Normally when you're developing code, when you check in new code, you want to run a bunch of tests, make sure everything's copacetic, and if something is not, then it emails a lead contact and then says, whoa, there's a bug, we need to fix it before we move on. You can use that same infrastructure using this freemium model, meaning GitHub and Travis that does the continuous integration. They set it up so that if you make it publicly available, then you can use their services mostly for free, most all of them actually. And in this case, we very much want it publicly available. We want everybody to know about how the ecosystem is faring in the National Marine Sanctuaries. So we can use that to then run this and go and fetch data from OBIS and ERDAP and DataOne and NASA and other APIs to grab the latest, greatest, and then update the website, which is the condition report, which is a Word doc, which is a PDF. So here's an example of the condition report. This is very much in progress, just like the very beginnings. This is called something called Book Down, where you get this little hamburger thing. You get a menu. You can do a search, so I can look for a map, or you can change the font, and this just comes pretty much out of the box. I can go to edit this, and now I'm in the page where it edits. So our Markdown is set up where there's it's Markdown, which is it's like, I don't know if it's like Wiki. This creates a header, and then it weaves chunks of code in with rendered text. So that creates a header, and you can make bold and create links and do all the basic web stuff, and it weaves those two in together. So I can go and edit that, or I can just go and download it as a Word doc or as a PDF. And you can do other things, of course, like add a little cover. And then for that map, so like here's a little interactive map. It would just take a screenshot for a static document, like there. So it's very easy to generate this stuff that is up to date and online and available. And let's see, time check. Okay. This one also came out of Mbon. Actually, the first day I was officially hired with Mbon, Jen Brown, who works particularly with Monterey Bay National Marine Sanctuary, but all the sanctuaries, she approached and when asked, what do you want to see? She said, well, the integrated ecosystem assessment folks have done this beautiful job of creating these silhouettes of different habitat scenes. What I want to see is the data associated with those elements. So can you make that happen? And yeah, that's totally easy. We got D3. We could do anything visual. So so first I did some D3 stuff, and then Tyler here is also very much working on this with the Florida Keys National Marine Sanctuary. So we're actively advancing this. And the idea is that you can go to a given place, like a Channel Islands National Marine Sanctuary, and then you get a habitat overview. There's pelagic, sandy beach, rocky shore, and then you can click on one of those habitats. And then, okay, now you can see turtles and salmon and pinnipeds and squid and whales, phytoplankton and thermometer, and then you can click on you can click on one of these elements, and then you get a pop-up window that shows you a time series or a map or where things have been sampled. And then that data could be updated in daily or weekly. And this could all, again, be hosted for free. And it can use open source stuff, and anybody else can contribute towards it. So we're trying to build this out now for the National Marine Sanctuaries, and the integrated ecosystem folks have some really nice illustrators, and we're moving forward with that too. Yeah. So now this is going to be an R packet. It is an R package, but we're streamlining it so it can work in all kinds of contexts. So pretty soon you'll be able to, there'll be boxes of text with little arrows, and you could sequence through a story so that it could describe how on the West Coast we had a marine heat wave. So that started with temperature. Then we had phytoplankton blooms. Then the phytoplankton blooms released domoic acid, which affected pinniped pups, as well as it created one of the longest Dungeness crab fishery closures in history, and that's the biggest fishery in the West Coast. And then humpback whales switched prey, which brought them closer to shore, which entangled them with crab traps. So there's this trophic cascade of impact that is complicated to describe, especially the stakeholders that are being directly impacted. So to have this kind of tool that could communicate to the public, and even in a way that you don't even, like in Senegal, there was a lot of people who couldn't read, but they could actually look at this and get the idea. And that's a very powerful communication device to people who are affected by policies that are a consequence of data. Okay, so now next section, let's get a little bit more interactive. And so these are, I already talked about the infographics, which is, I would say, in this category of R Markdown, meaning it's fairly static. You can host it without requiring that back-end server to do stuff. And most of the rest of what I'm going to talk about needs a more user interaction. So I'll just do a quick, brief overview of these. So this was a dissertation chapter for how do we site offshore wind to minimize impact to wildlife, particularly seabirds in space, because they have long-term operational impacts with the turbines. And things like pile driving impact acoustically and episodically migrating cetaceans. So we can do that. We can look at that trade-off. Similarly, we can look at a trade-off of hotspots where we see, say, whales that we want to avoid ship strike and suggest alternative routes. The Ocean Health Index I already mentioned, there's many, many layers. It's very nested. So we can reduce that into a single space, but then allow you to dive into deeper and deeper layers. Working with the National Renewable Energy Lab, there's a lot of ocean uses in the world, and where renewable energy, offshore wind, wave, and tidal can interact with human uses and other habitats and species. So how could you map that out so that a developer and a regulator know where the conflicts are most likely to occur and maybe mitigate those sooner than later? And then with the MBON project, there's eDNA, Ani's here. So how can you look at that environmental data and describe it. And then connectivity. So how can you look at how what the import and export of larvae is by advecting larvae for a given place. And then this is another SDG Explorer. And yeah, we'll see how far we get. And then I'll show you, how this stuff gets built. Okay, so all of these are interactive, online, open source. So Shiny is a package of R, but there's also a server side that hosts this. And what it does is it allows you to create a user interface just using a bunch of R functions, interact with arbitrary server functions of your choosing to then update outputs. So it can update a map, it can update a plot, it can create another user interface. And it does it in a way that makes it very easy, so you don't have to be a web programming superstar. You can just know a few principles and get a lot done. And then some themes are, so exploring trade-offs. When you can have a plot in variable space that is a trade-off, say, between maximizing profitability to the offshore wind industry while minimizing risk to wildlife on 2 axes. And then each point then associates with a pixel on the map. And you can play with those two. It becomes very useful for stakeholder-driven exercises because everything's a trade-off. Reductionist, so that's like the Ocean Health Index. A lot of data going in, summarizing to a single score. So you can give it to the decision maker. Those who want to know more, they can dive deeper. And really, it's about making decisions. And dimensional data, and storytelling, data-driven storytelling is like the infographic. So this is what the app looks like for the offshore wind, and it's similar with the routing. So in both cases here, we've got a trade-off curve. So there's color coding. So we could separately map out for each pixel, each 10 square kilometer pixel, we can map out what the bird sensitivity is and what the wind profitability is. And then show that color-coded as the overall utility function on a map, as a map surface. Similarly, so that's conflating all the bird scores. And then we can click on a given spot and say, when are cetaceans present that are most endangered, that we care about? And maybe we should avoid those times, and there's a minima throughout a year. And then for the routing, you can collapse all the density surface models of these marine mammals separately that we modeled and say, okay, where's the hotspot? Based on a weighting of endangered, where do you, if you're going to open up Port Kitimat to oil tanker traffic, which was being proposed, and it would be the first time since Exxon Valdez that oil tankers were going to be allowed in 20 years in the inner waters of British Columbia, then how would you route